So our next unit is going to be a lot of algebra. I need to teach you some algebra so we can start working using that algebra to do some geometry work. So a lot of this is going to be review from your algebra course last year, and then some of it might be a little new. Maybe you have seen it in algebra last year, maybe you haven't. So let's take a look at radicals, okay? So our worksheet, lesson 8.1, is on radicals. And what do we mean by a radical? Well, a radical is a root function. I'll put root in parentheses like that. And you're used to seeing these written as like square root of something, square root of a. We can do other roots. There's cubed root of a. We can have fourth root of a. So this just tells me this is what's called the index. Not that I really need you to know that, but it's telling you which root it is. And it's not too hard to do because like the square root of 16, well, most of us know square root of 16 is 4. The reason because 4 times 4 is 16. So it's the opposite of squaring something. The cube root of 8. So what times itself times itself times itself will give me 8. Well, 2 times 2 times 2 is 8. So the cube root of 8 is 2. I'll be honest, I don't know most cube roots. I know 8, cube root of 8 is 2, cube root of 27 is 3. Beyond that, I don't know them. But it is something to think about. You may see these cube roots or fourth roots are bigger. So just sort of come up with some numbers that might work. And it takes a little guess and check sometimes. We tend to focus more on the squares, though, especially perfect squares. And these are important. You need to know these perfect squares. If you can't remember them, make a list of them. So the perfect squares, 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5, 25. 6 times 6, 36. 7 times 7, 49. 8 times 8, 64. 9 times 9, 81. 10 times 10, 100. And we start getting into some that you might have a little trouble remembering. 11 times 11, 121. 12 times 12, 144. Now we push it to the even more limit. 13 times 13 is 169. And here's a neat one. 14 times 14, 196. If you can remember this one, you can remember that one. Just switch the last two numbers around. And that's usually enough. If you remember 15 times 15, even better. But these are pretty much the ones I remember. These are important because they're going to help us break down square roots. Okay, something you did last year. Because any root can be written, if it's square root of a times b, can be written as the square root of a times the square root of b. Okay, that's just the way we can write any kind of product in a root. Okay, whether it's square roots, cube roots, it doesn't matter. For example, now we know the square root of 100 is 10, but let's say you didn't know that. Let's say you didn't remember this list of numbers here. Well, I could take the square root of 100 and I could say, well, I do know 4 times 25 is 100. So then I could break that up as the square root of 4, square root of 25. And then I go, wait a minute, I know the square root of 4. The square root of 4 is 2. I know the square root of 25, so times 5, which gives me 10. Okay. Notice that once I take the square root, I don't have that symbol anymore. I've used that symbol up. Okay, so basically that's what we're going to be doing. And again, you did this last year, simplifying a square root, 72. Now, one thing I like to do, don't just start randomly choosing numbers that go into 72. Go back to this list. Okay, now 72, any square root has to be smaller than the half. So I'm not going to choose 81. 81 won't go into 72. 64 is going to be too big. Maybe I'll start at like 36. And if I use my calculator here, so 72 divided by 36, oops, you can't see that, gives me 2. So 36 times 2. So I'm going to say I can break this up as 36 times 2, which then I can break up as square root of 36, square root of 2. But I know what the square root of 36 is. Square root of 36 is 6. I don't know the square root of 2, so I'll leave it as times the square root of 2. And there's my solution. Whoops, take that piece off of there. So my answer is 6 radical 2. 48. Well, I know half of 48 is 24. So when I go back to my numbers here, I'm going to choose a number less than 24, maybe 16. So 48 divided by 16 is 3. Excellent. So I can go, great. This can break up into 16 times 3. So that's the square root of 16, the square root of 3. And the square root of 16, I know, is 4. And there we go. I don't know the square root of 3. I can't figure the square root of 3. It doesn't break down, so there's my solution. Why don't you try a couple of these? Try these 4 problems here, and then we'll go over them, okay? When you type into this square root, like if I wanted to type in 4 square root of 3, I would type in 4 SQRT parentheses 3. Okay, so that's how I would type this into an answer. If I'm typing this one in, I would type in 6 SQRT parentheses 2. So type your answers like this for these problems here. Okay, give it a shot. I'll give you some time. Okay, so square root of 80. Let's talk about the square root of 80. So I'm going to break that down. And using my square roots, I can say, let's see, 80, I'm going to divide it by half of 80 is 40. So I'm not going to use any square root, any perfect square that's bigger than 40. 36, oops, doesn't work. 80 divided by 25, oops, doesn't work. 80 divided by 16, there we go. So I can break this up as 16 and 5, but I know the square root of 16 is 4. So 4 square root of 5 is my solution. Okay. 50. Well, 50 you probably got real quick because you already know that 2 times 25 is 50. Now be careful. When I write it like this, I don't know the square root of 2. But I do know the square root of 25. The square root of 25 is 5. Square root of 2, well, I'll leave it as square root of 2. Okay, you can change that order. It doesn't matter. Just remember that, hey, I know the square root of this number, so I can make that there. I know the square root of this number, so I can turn that to that. Let's look at 125. You know what? I think 25 might go into that. Usually if it ends in a 5, I'm going to try something that's got the 5s on it. Let's see if we can help see this a little better. You guys can't see that at all, can you? All right, well, I've taken 125, and I'm going to divide by 25, and that gave me 5. Okay? So let's say 25 and 5, square root of 25, square root of 5. But the square root of 25 is 5. So this piece became that. And the square root of 5, I can't do. So I'm going to leave it as 5 times the square root of 5. Square root of 450. Ooh, okay. Let's go some numbers here. 450. Let's try 25. Hey, 25 and 18. Okay. 25 and 18. And the square root of 25 is 5. But I can break 18 down because 18 I know is divisible by 9. So I'm going to do it again. I keep my 5. 9 times 2, so square root of 9, square root of 2. And the square root of 9 becomes 3. And I'm still multiplying. All this is multiplied. So my final answer is 15 square root of 2. Could have done this quicker if I went straight to whatever 15 squared is. I think that's like 225. Let's see. Yeah, if I'd done 225, I could have done this way faster if I'd gone, hey, 225 times 2 is 450. And then that breaks down into 15 radical 2. So you can, all right, so I had a little bit of a computer glitch, so let's finish that up. I had to do some editing. I said that the 225 square root of 2, square root of 225 is 15. So that's a way you can get there faster by using larger square roots, but there's nothing wrong with this method, okay? Now, this is all similar to what you did last year, but let's add another level to it that you may not have done last year. Let's look at radicals with variables involved, okay? Square root of x and x squared are inverse functions. Okay, kind of like plus and minus, multiply and divide. Okay, this means that they cancel each other out. I'll put cancel here like this because I hate using that word. Each other out. Okay, they bring each other back to their beginning. So the square root of x squared, so the square root and the squared cancel, leaving me with just x. This is true for any roots. The cube root of x cubed, cube root and cubed cancel out, leaving you with just the x. But the square root of x cubed, well, that's two different things. So, but I can do this. I can say x cubed is just x squared times x. And then just like we did with the numbers, I can break it up like that. So x squared and x. This whole thing, square root of x squared, is x, and the square root of x I can't break down. So we do the same process that we did with numbers. So let's take a look at a couple examples of that. Square root of x to the fourth. Well, that could be x squared and x squared, which is just x times x, which is x squared. So if you've got an even exponent, you can divide. It's kind of a little secret. Here, I got an odd exponent. So I'm going to break this down as x to the fourth and x. That'll give me x to the fifth, which now I can say that's x to the fourth and x in the square roots. Square root of x to the fourth is x squared, and I'm left with the square root of x. Okay? Square root of x to the sixth, remember squared roots, that's a 2 index. 6 divided by 2 is 3. Okay? So you're dividing by 2 to get this down to here. Divide by 2 gets you to there. If I divide 5 by 2, though, I don't get a whole number. So I break it apart. Okay? So let's try a couple of those when we mix the numbers in. Numbers apply just like numbers do. 30. Let's see. What goes into 30? Well, half of 30 is 15. So if I go back to my numbers, the only thing I can look to put into there is 9. That doesn't work. Or 4. That doesn't work. So 30 doesn't break down. But a to the 34th, that does. That's an even exponent. So that means I have a to the 34th can break down using my even exponent. I do what is half of 34? Well, half of 34 is 17. Square root of 30, however, stays exactly like it is. So this came to here. Square root of 30 doesn't change. And there's my solution. Okay? Little tricky when you get to numbers. Remember, numbers act like numbers. Exponents act slightly different. Let's look at 54. 54 I might be able to break down. Let's see. So 54, if I divide that by, let's try 16. Nope. 54 divided by 4. Nope. 54 divided by, well, 27 is the half, so maybe it doesn't break down. By 9, 9 and 6. So I'm going to take my 54, and here's what I like to do sometimes. 9, 6. Okay, that's breaking up 54. X to the fourth, I'm going to keep that with the perfect square. Y to the fifth. I'm going to put 4 of them there with the perfect square, and 1 of them there with the non-perfect square. Same with z. Z to the sixth, and another z. So now my perfect squares go into one root. 9, x to the fourth, y to the fourth, z to the sixth. Under another root, the imperfect squares. Now I can take my square root. Square root of 9 is 3. X to the fourth, half of 4 is 2. Y to the fourth, half of 4 is 2. Z to the sixth, half of 6 is 3. And this stays the way it is. And there's my solution. Okay, so it takes a little extra work on these. Give it a try. I'm only giving you 3 problems here. We'll go over the answers, and then we'll practice some more to this. Go for it. Okay, x to the 11th. 11's an odd number, so I'm going to break it up. with an even number, 10, and a single. Half of 10 is 5. Square root of x. Same idea with the square root here. 18. All right, 18. Wait a minute. I'm going to break that up as two things. 9 times 2 is 18. X to the fourth is a perfect square. So that is going to break down to 3x squared square root of 2. Okay. And my last one, 40. So let's see. 40 will be 4 and 10. 10 won't break down anymore, so it's a good number to use. 4 is a perfect square. X to the fourth, that's an even exponent. Y to the fifth, so y to the fourth, and another y. Z to the third, so z squared, and another z. Square root of 4 is 2. Half of 4 is 2. Half of 4 is 2. Half of 2 is 1. 10yz. Okay. This is what we'll be doing tomorrow in class. We're going to be breaking down and simplifying these square root functions. Okay. So practice on that. Memorize your perfect squares. And if you can't memorize them, write them out. Okay. Tomorrow, don't just come back to this list. Write them out on your paper and say it to yourself 2 times 2, 3 times 3, 4 times 4 until you've got them memorized. Okay. That's all we've got. Messing up again. So have a great night.